Welcome to Carlton's Math Corner. Today we're going to discuss systems of equations. At this time, please make sure that you have your math journal, your vocab packet, as well as something to write with. Our targets today is I can determine the number of solutions in a system of equations. I can solve systems of equations by graphing. First of all, let's talk about what is a system of equations. Well, basically, it's two or more equations, and they're linear equations, and we're kind of comparing them to one another. So we're taking two straight lines, and we are trying to figure out how many solutions those two lines have. And so our system of equation can have either one solution, an infinite number of solutions, or no solution at all. And down here is kind of the categories that we put them in. So no solution means that we have two parallel lines and these lines will never, ever, ever touch. So we have linear equations that they'll just never touch when we graph them. One solution means that the two lines cross at one point, and then infinite number of solutions means that the lines actually lie straight on top of one another because they are the same line. And when we talk about no solutions, we say that that is an inconsistent system of equations. And then one solution and infinite number of solutions, we call them consistent because they do have a solution, or they have more than one solution. And a system of equation that has one solution is called independent because both of those lines are independent of each other. They don't lie on the same line. They only cross at one point. And then infinite solutions are called dependent because they depend on each other completely. They are the same line. They share an infinite number of points on a coordinate grid. Okay, so let's look at our first problem that we have here. This is titled You versus a Horse because you go for a run and you run 0.2 or 0.2 kilometers every minute. Now your friend decides to go horseback riding and she rides 0.5 or 0.5 or 1/2 kilometer every minute. Now, when your friend is riding, though, it takes her 6 minutes to saddle up her horse. Okay, and so the question is, will your friend ever catch up to you? Because you will start, at 0 seconds or 0 minutes, you will start right away and you will start running. Then your friend, will start 6 minutes later. And so because she has to saddle up the horse before she starts. And so we're trying to figure out, will they ever catch up to each other? Okay, and so let's look at this. Let's take everything that we learned from the word problem and kind of see if we can create, an equation from it. And looking at this, okay, so the first thing that we learned is that you can run 0.2 kilometers every minute. Your friend can go on horseback riding or on a horseback and can ride at 0.5 kilometers every minute. However, she needs to start 6 minutes later. And so what I want you to see are the steps below on how it was solved to see if they would eventually, if your friend would eventually catch up to you. Well, what is happening? Like, what steps are going on? Well, the first thing that I notice is that it looks like equations were created for you and your friend. And so let's start off with the 0.2 kilometers every minute. Well, if I'm creating a linear equation, I'm going to start with y equals, because linear means I can plug in a number for x and I can get a number out for y. And so I need an x and a y for my ordered pairs that go on a coordinate grid. And so I'm going to start off with y equals, and I need to write 0.2 kilometers. Now, in a previous video, we learned that slope helps us determine how much a line rises over how much it runs. And if we look at a decimal, that's really hard for us to determine rise over run. And so it's actually better to write it as a fraction. And so if I take 2/10 and put it as 2/10 as a fraction, then I can see my rise over my run. And I know 2/10 I can simplify, so I see that as 1/5, because 2 divided by 2 is 1, and 10 divided by 2 is 5. And then notice x is next to it, because this word every minute, every single minute, you can run 0.2 kilometers, or 1/5 of a kilometer. And so every minute we're going to multiply by that 1/5. And so I'm going to use x because I'm working with a coordinate grid, so I need an x and a y. So x is going to represent minutes, y is going to represent how fast you are running in kilometers. And so now if we look at the friend, now the friend travels 0.5 kilometers, which is the same as 5/10. Well, 5/10 is the same as 1/2. So 1/2 kilometer every minute. So that looks similar to this up here, except for there is a difference in how fast they run. But notice the -6. Now the -6 is because we got to take away 6 minutes from that time, because of the fact that your friend has to saddle up her horse. And so 6 minutes is subtracted, and so our equation looks different. Now, what do you notice is the next step after creating these equations? Well, it looks like actually these lines were plotted. And we've learned in the past how to plot a line. Remember, we always start with the y-intercept. And our y-intercept in this case for u is 0, because there's nothing there. So we started at 0 in the middle, at the origin. Then we needed to rise 1 and run +5. So rise 1, run +5. Rise 1, run +5. And I could keep going and keep going and keep going until I figured out where my lines were. Same thing with your friend. This time I start at -6. So notice there's my y-intercept. It's at -6. And I need to rise 1, run 2. Rise 1, run 2. Rise 1, run 2, etc. And notice it looks like we had to keep going quite a bit, because look what happened. We actually figured out that these lines will cross, because if you look at these lines, they're definitely not parallel with one another, and they are definitely not the same line. They don't have the same slopes, and they don't have slopes that are opposite of each other. And so when we're looking at this, we're trying to figure out then where it crosses, because that is where we would figure out how much time it would take and how many kilometers they have ran. And so looking at this, it looks like they cross at 24, meaning x represents minutes, so 20 minutes. It would take 20 minutes for you and your friend to catch up. And you both would have ran at that time 4 kilometers. Now we call this a consistent system of equations. It has one solution, and those lines are independent of each other. They don't share an infinite number of points or anything. They only share one point. Okay, let's look at another situation. And before we do that though, let's talk about what were the steps that we took. Well, the first step was we created two equations in slope-intercept form. We graphed those equations using the slope and the y-intercept. And then we determined kind of how many solutions the system of equations had. So if the line crossed once, which it did, it had one solution, and it's called consistent and it's independent. If the lines were identical, meaning they were right on top of each other because they had the same slope and the same y-intercept, that's called an infinite number of solutions, and that's an consistent and dependent system of equations. And then lastly, if our lines were parallel, they would have no solution, and we call them just inconsistent because they will never ever share a point. So let's look at another situation. This is not a word problem. This is just, a system of equations, and it's written as just equations. Like this is my system right here. And I want you to notice the same steps were taken. So here's my system, and notice both systems were written in slope-intercept form. And we learned how to do that in a previous video. And remember, just to write in slope-intercept form, I'm trying to get y by itself, and I just need to add or subtract my x and any additional terms that are on the same side as the y. And so I'm moving them over to the other side by adding or subtracting. So notice I had to subtract the x because that's the inverse operation to move it to the other side. And if I subtract x, I get a minus x or a negative x. And then that's really all I had to move. Notice I wrote it though as slope comes first, then y-intercept. And then lastly, this one, it looks like all I had to do was add 3x. And so I added 3x on the other side, and I get positive 3x, and then plus 2, because that 2 is still there. And so graphed it, and I noticed that again, this has one solution. So this is a consistent system of equations, and it's independent of each other. Okay, so what I would like you to do is I want you to try out this system. I want you to get both equations in slope-intercept form and then graph it and see how many solutions this system has. Okay, thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.